Now let us learn another important application of derivatives, which is Rolle's theorem. Rolle's theorem states that if f of x is continuous in the closed interval a to b, and if it is differentiable in the open interval a to b, and if f of a is equal to f of b, then there exists some value c in the open interval a to b such that f dash of c is equal to 0. Now let's understand all these terms one by one. First of all, the three conditions are mentioned for the Rolle's theorem. So the Rolle's theorem is valid or applicable only for those functions which satisfy these three conditions. First is that the function is required to be continuous in the closed interval a to b. Okay. Similarly, it should be differentiable in the open interval a to b. Now you may wonder why for continuous we have closed interval and for differentiable we have open. Simply because at the end points the differentiability cannot be discussed, right? It is simply invalid. So therefore we don't include the end points while considering the differentiability. And the third condition is also very important, that is the function should have the same value at the end points of the interval given. So f of a should be equal to f of b. So if these conditions are met, then the Rolle's theorem states that there exists some value c. So it may be one or more than one, but at least one value exists in the interval a to b such that f dash of c is equal to 0. That means the derivative of the function at that particular value c is 0. Okay, so let's understand what does this mean graphically. Okay, suppose we consider some function. Okay, now here the function I have drawn such that the interval is a to b. As you can see, the graph is without breaks, so therefore the continuous function is seen. Then the graph is also smooth, that means at every point on the graph we can draw a unique tangent, so that means the function is differentiable. And if you see at the end points a and b, the value of the function is exactly same. Okay, so they are at the same horizontal level, as you can see visually, right? So therefore f of a is equal to f of b. Alright, now let us interpret what does the then part of the statement means. There exists c such that f dash of c is 0. We know that geometrically the derivative represents the slope of the tangent. So that means here what the theorem is saying in other words is there is at least one tangent to the curve which has the slope 0. That means the tangent is horizontal, isn't it? So that means here, looking at the figure, we can easily sense that yes, we can think of a tangent at the peak point, and that point corresponds to some value c such that the slope of the tangent is 0. That means the derivative of the function at value c is 0. So therefore the Rolle's theorem is verified for this particular function whose graph is drawn. Now as we saw earlier, it is not mandatory that there is only one value of c. There might be more than one also. For example, if you think of the function something like this. Now here in this case, once again the graph is continuous and smooth, so it is the function is continuous and differentiable, and at the end points it has the same value which is a and b. Now here you can see that not one but we can draw two horizontal tangents to the function within the interval a to b, correct? So there are two possible values of c, we may call them as c1 and c2, where the tangents are horizontal. That means the derivative is 0. Okay, so that's the interpretation of Rolle's theorem. Now let us solve one question based on Rolle's theorem. Verify Rolle's theorem for the function f of x given by x minus 1 into x minus 2 into x minus 3 in the interval 1 to 3. Okay, so x belongs to the interval 1 to 3. We have to deal only with this particular interval. Now since we have to find out the derivative, it will be easier if we first expand this particular expression. So therefore we will get x minus 1 into x square minus 5x plus 6 so that gives x cube, correct, that's the x into x square product. Then we have minus 6x square, then we will have plus 11x and minus 6, right? So that's the expression for the function. Now let us keep ready the derivative also. Therefore we know that f dash of x is equal to 3x square minus 12x plus 11. Now let us quickly check first of all whether the function satisfies the eligibility criteria for Rolle's theorem. If you look at the function given, it is a polynomial in x, and we know that all the polynomial functions are always continuous and differentiable on their domains. Okay, so clearly this function is also continuous and differentiable on all of its domain. So it has to be, of course, continuous and differentiable over the given interval which is a part of its domain, that is 1 to 3 also, right? Then we have to also check whether at the end points, that is f of 1 and f of 3, whether they are same or not. Now clearly when you put x equal to 1, the first bracket will become 0, thereby making entire f of x 0. Similarly when you put x equal to 3, in that case also the entire function will become 0. So yes, we have satisfied the third condition also for the Rolle's theorem. Now since all the three conditions are met, it means that we should be able to find some c in the interval 1:3 such that f dash of c turns out to be 0. Okay, so this is what we have to verify. So we have to prove that there exists some value in the interval 1 to 3 where the derivative will become 0. So here we follow an indirect approach, that is we start by considering f dash of c equal to 0 and solve for the value of c, and then show that that value must lie in the interval 1:3. Or if we get multiple values of c, then we show that at least one of them guaranteedly lies in the interval 1:3. Alright, so now since we have got f dash of x, we can readily get f dash of c merely replacing x with c. So therefore f dash of c equal to 0 implies 3c square minus 12c plus 1 equal to 0, which is a quadratic, and we observe that it's not easy to factorize this into simple integers, so therefore we straight away go for the quadratic formula. So that is 12 plus or minus b square, that is 144, minus 4 into 3 into 11, that is 132, times 2 into 3, that is 6. So therefore solving further we get c is equal to 12 plus or minus 144 minus 132 is 12. So square root of 12 can be written as 2 root 3 whole upon 6. So further we can divide by 2 and we can write it as 6 plus or minus root 3 upon 3, that is equal to 2 plus or minus 1 upon root 3. Right. Now here we have to ascertain these two values which we have got. If you observe, the value 1 upon root 3 is clearly less than 1. So therefore if you add or subtract that value from 2, clearly the answer will be lying in the interval 1:3 only. So therefore both of the values of c that we have obtained definitely belong to the interval 1:3. Therefore in this way we have verified the Rolle's theorem for the given function.